Okay, geometric series. Geometric series is the sum of a certain number of terms. You're adding or subtracting them. So instead of 1, comma 2, comma 3, comma 4, you're having 1 plus 2 plus 3 plus 4. A geometric series is one that grows geometrically. So instead of adding or subtracting the same one, each time you're multiplying or dividing. An infinite series is a series that continues forever. Now with arithmetic series that are infinite, you cannot add them all together. However, if you have geometric series, they can add together. You can add together an infinite number of terms and find a finite sum or a finite total. The key to this is, what is your R? If the absolute value of R is less than 1, they converge and you can add them together and find a total. If it is larger than 1, if you're, let's say, multiplying by 3 each time, it grows infinitely, it diverges, there is no total that you can find. But you can add an infinite number of numbers together and get a total. It'll make a little more sense when we get there, hopefully. So here are some new formulas we're going to have. The first one, the geometric sequence formula, once again, is a review. How do I find a particular term number? I take the first term times the ratio r to the n minus 1. Here's the summation notation, which is the sequence formula going from n equals 1 to whatever. We don't do them very big because, man, they can grow fast in a hurry. Now, if you have a finite series, if you have a finite, this is for finite. In other words, they end. You can add up a finite number of terms, the n number of terms. Some of those first terms is a sub 1 times 1 minus r to the n. So you take r to the n, subtract that from 1 first, times a sub 1 divided by 1 minus r. Now, if you have an infinite geometric series, it's a little bit actually easier to do it. You take the first term and divide that by 1 minus the ratio. But remember, in order for this to work, the absolute value of r must be less than 1. So if I have r as a fraction less than 1, it'll work. Okay, now, so here we go. Find the sum with or without, with and without. So first thing you do to find it with, you just add them all together. Negative 15 plus 30 minus 60 plus 120 minus 100, 240 plus 480, and you add them all together and you get 315. That is not a very large sequence. It's not that big a deal. Now, however, if I want to find it using the formula, I need a couple of things. I need my first term, which I have. I need the number of terms, and I have 1, 2, 3, 4, 5, 6 terms. So n is equal to 6. And then r is negative 2. How do I get from one number to the next? I multiply by negative 2. So my formula, the sum of the first 6 terms, it's the first term, negative 15, times 1 minus r, which is negative 2, to the nth power, which is, in this case, it's 6, all divided by 1 minus negative 2. And you plug that into your calculator, you work it out, and you get 315. Same as you did when you were adding it together one term at a time. Okay, find the following sums. This one actually works out pretty easy because you just use the formula. So the sum of the first 5 terms is the first term 12 times 1 minus r, which is negative 3, to the nth power, which is 5. And notice this is all in parentheses. You have to work this out first, divided by 1 minus r. And the first 12 terms is 732. Doesn't seem very large, but remember, our r is negative 3, so we're taking a positive plus a negative plus a positive plus a negative plus a positive plus a negative. So it's changing sign every other time. If r was positive 3, that would be a much larger number because it wasn't adding, subtract, add, subtract, add, subtract. Okay. Next one, this one isn't too bad. It's actually kind of nice if you look at it here. So find the first, sum of the first 6 terms. S sub 6 is the first term 2/3 times 1 minus r, which is 1/3, to the nth power, which is 6. And once again, that whole thing is parentheses divided by 1 minus r, 1 minus 1/3. Now, here's something really slick on this one. What is 1 minus 1/3? 1 minus 1/3 is 2/3. Ooh, look, these two cancel. This doesn't always happen, but sometimes it's really sweet when it is. Those two cancel. And my total is actually 1 minus 1/3 to the 6th power. And that ends up being, and if you really want to work this out in your calculator, you get 1 minus 1 over 729. 3 to the 6th power is 729. So make this into 729 over 729, and you get 728 over 729 is what my total is. Moving on to the next one, and oh, this is a nice quick lesson. I like that. So find the following sum. So here's what I need. I need my R. What's my R? My R is 3. R is 3. I need to know how many numbers I'm adding together. That's 6. I need to know my first term. Now, my first term, students always assume that, ooh, it's N. Sorry, my N is A in this case. It's always the number in front. Not always. Depends upon the formula. Yes, I have 3 raised to some power. That gives me my R. It's not always the number in front. It's not always that number there. You have to be careful. What I say to always do, always, 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 to find the first number, let N equal 1. Now, in this case, you do get 2, but what if it wasn't N plus 1? And what if that was 3 to the nth power? That was 3 to the nth power. My first term would not be the 2. My first term would be 6. What if that was the N plus 2 power? Because it could be any power. Then it would be something else altogether. Don't assume that it's the number out in front. Put in 1 for N and make sure you get the correct first number. I cannot emphasize that enough. Now, once I have those 3 things, I have my formula. So the sum of the first 6 numbers is the first term, which is 2, times 1 minus r, which is 3, to the 6th power over 1 minus r. And you work that out, and you end up getting 728. Okay. Now, the next ones here are the arithmetic or geometric. Remember, if it's linear, if you're multiplying n times the number, then it's arithmetic. If you have some number raised to the nth power, it's geometric. This is arithmetic, and our d is 2. This is geometric, our r is 4. This is geometric, and our r is -7, because it's a -7 to the power. This is geometric, and our r is 3. This is arithmetic, and our d is 1/6. Then this is geometric, and our r is 5. Nice, easy notes. And here's our last page. And these ones are infinite series. Do they converge? Do they diverge? If they do converge, then we have to figure out what our total is. And the formula for this is a much easier formula to use. So the first thing we have to do is figure out what is our R. How do I get from one number to the next? In this case, to go from 1 to 10, 10 to 100, our R is 10. That's larger than 1. This one diverges. Okay, it diverges. It grows without bound. It does not get to a finite number. It doesn't work. I can't find the total. Okay, so this next one, how do I get from 32 to -16, -16 to 8, -4 to 2, sorry, -8 to -4? This one is, my R is -1/2. I take half of each number because it changes sign every time it's negative. So this one converges. If it converges, I can find the total. So the sum, the infinite sum, is equal to the first number, 32, divided by 1 minus R, 1 minus -1/2. And I add them all together, and I get 64 thirds. That's what that adds up to. If I add up all those numbers infinitely, it will approach 64 thirds. Will it actually be 64 thirds? No, but it will get so close, it doesn't really matter. Okay? So let's take a look at this one because this next one really, really explains it all. How do I go from one to the next? My R in this case is 1/2. I take half of each one, right? Think about you're walking towards a wall and you go half the distance every time. So I get half as close, I get half as close, I get half as close. How far did I actually travel when I end up stopping, when I stopped going there? I traveled the distance from where I began to the wall. I only covered half each time I did it. Each iteration, I went half the distance, half the distance. Do I actually ever touch the wall? Well, physically, yes, you will touch the wall because you cannot do half the distance when they get really small. But you understand, theoretically, we would never touch the wall. But that distance between you and the wall becomes so small that it doesn't really freaking matter. And so how much distance we covered? We covered from where we were to the wall, however far that was. That's what we're doing here. You're covering half the distance and half the distance and half the distance. So if I'm only going half each time, I do have a finite distance I'm traveling. That kind of hopefully helps you understand it. So the sum of my infinite series, and I like to put that, you don't have to put the infinite part, is my first term, 1/2, divided by 1 minus my R, which in this case is also 1/2. And if I add up 1/2 plus 1/4 plus 1/8 and plus 1/16, I get 1. Okay. So let's take a look at this one. This one's actually pretty easy. My R is -7/8. Is the absolute value of -7/8 less than 1? Yes. Yes, it is. This means I can do it. Now, my problem is I have to figure out what my first number is. I have to figure out the first term, a sub 1. Always put 1 in the formula and make sure you get the right first term. Do not make any assumptions. So I put in 1 for n. 1 minus 1 is 0. Anything to the 0 power is 1. So what's my first term? My first term is 1. So the sum, my infinite sum, is 1 over 1 minus -7/8. And you work that out and you get 8/15. So I start with 1 and I add negative, and then I add -7/8 to that, and I multiply out, and so on and so forth. Okay. This one, my R is 5/4, which is greater than 1, so this one diverges, which means we can't find the total. This one, my R is 2/3, so I can find the total. First thing I need to do is I need to figure out my first term, a sub 1, 4 times 2/3 to the 1 plus 2 power. And plus 2, 1 plus 2. So I have 2/3 to the 3rd power times 4, and you figure that out, and you get 32/27 for my first term. It's not 4. And that would be the assumption that many of you would make, is that, ooh, 4 times something to a power. It's that, no, you plug in 1 for n. Make sure you get the right first number. So now I want to find the total. So the sum of the infinite sum would be the first term, 32/27 over 1 minus my R. In this case, it's 2/3, 1 over 2/3. And you end up getting 32/9 is my total. So yes, you can add together an infinite number of numbers if they're the right set.